Hey all, today we'll be looking at the practical implementation of this boosting and lagging techniques. So we have had proper discussion on this theory topics. Now let's run and try to have a basic understanding of how practically we can implement these algorithms. First of all, I'm going to implement the one algorithm known as Adaboost. So I don't have to explain much about it. Let's try straight on try implementing the practical implementation of it. So let's move and go to the implementation step. So here first we'll try to run the cell and import pandas and PD and numpy and NP for this all processing long stuff. Next we'll be loading our dataset. So it is in the iris.csv file. Before we start, let me tell you we are using the iris dataset for the purpose of our testing model. So iris dataset is nothing, it contains about some of the plants and flowers. Okay, and based on their sepal length and petal length and petal width and sepal width, we are classifying them into various classes, some such as versicolor, virginica, and all. Okay, so we'll read this CSV file, and now let's have a look at how our dataset looks like. This is how our dataset looks like. It has various classes, setosa, and also various classes. So let's add another cell and try to iris.ilo. What location it is? 0, 1, 2, 3, 4, 5. ilo 5 dot unique. And let's see what all classes we have got. So okay, I think we have got the wrong class. Let's have and try to exit it by name. Let's have this column species. Okay, these are all different classes which we have to classify based on these four features. One is iris, setosa, versicolor, and virginica. Okay, let's have some information about our dataset. So okay, all of them are not null object. Some of them are, one last column is the categorical feature, basically the classification feature, and rest of them are integer and float, so it's not required for any possible reprocessing. And also there are no null values, so we don't have to worry about it. Let's create target and feature vector. So for the feature purpose, we are using these four columns, and for the output purpose, we will be using species column. Let's have an this cell. Okay, and for the output, we are using a species column. Now, since our output is a categorical feature, it makes basically a string and object, you can say, we will be using label encoder to convert it into in the form of numbers. For example, setosa turns to be 0, and virginica turns to be 1, and versicolor is turned to 3. So that prediction becomes easy for our model. Okay, because we can't work on categorical data, whether in the form of features or whether in the form of output. So we basically tend to convert into numbers. So we are using label encode, and we'll run it. So now if we try to see our y.head, before it was like this. Okay, you were having some objects, but now it is in the form of numbers. Okay, let's print 5 of first 5 of 0 to 5 basically. 0, 4, 5. So these are all now in the form of numbers. If I tend to look some it will say other values. Okay, starting with 0 only, no worries. If I try to print unique values here now, okay, it doesn't have any unique object, but the purpose is let me print. So you can see that before it was like these values categorical. Now it is having values in the form of integers. Okay, now let's run a test and train script, and we'll now build our Adaboost model. So basically what we are doing, we are importing our Adaboost classifier from the sklearn.ensemble, because classifier Adaboost is an ensemble technique, and we'll create a Adaboost classifier with these following parameters. We'll be using 50 estimators, learning rate as 1, and random state as 0. So what basically number of estimators see, we'll be using 50 decision trees. Okay, and this will run and predict. Let's see what happens. What has run the predictions, and we'll try to evaluate the model. For the evaluation purpose, we'll be using accuracy score. So let's run this. See what's the accuracy. Now it has having a 93% accuracy. So initially, there are some parameters we can tune in order to get the best performance. By default, the base estimator was decision tree for this Adaboost classifier. Now we can also use support vector classifier for as a base estimator, and let's see at how the model accuracy changes. So we'll be using a support vector classifier here, and we'll try to run this and see what is the change in accuracy. Now the accuracy is still the same, but it might get changed in some cases. Okay, so let me run it again. It's giving 93% accuracy for now, but usually it improves or maybe decrease or change with the help of this change in the classifier, and basically the base estimator. So next we can look on something called gradient boosting. So gradient boosting we have already seen. So let's import pandas and numpy and matplotlib for visualization. We'll be having our train and test data in the form of this. So what we are basically doing, we are trying to evaluate the Titanic dataset. So in Titanic dataset, we have some features. Based on that, we have to predict whether this person is going to survive or not in the Titanic crash. Okay, so we will be setting some indexes. We will be deciding our target feature is the survive. Okay, let's have a look at this by inserting a line here. Let's have a look at train.head, how it looks like. So these are all the features. This is the target feature, the survive column, and remaining are the input features. Okay, so this is the column which we are looking at. We'll drop the survive column, and remaining will become a train dataset. Okay, let's see the train and test shape. So it is like this. Okay, now we'll take merge them and make the new dataset, and we'll drop some of the columns, and we'll get the dummies of this gender variable, because it is a categorical feature. So we'll run pandas get dummies, and now we can see the shape has increased. Now in the next step is, if there are any missing values in these columns, we'll be filling with them 0. Now we'll be dividing into test and train data. Now let's see the train and test step, which looks like this. Now we'll be using min-max scalar for the easy computation and the fast things. And now next we'll be doing train test split. Now finally we have to come to the stage where we are using gradient boosting classifier. So we are importing gradient boosting classifier and some of the evaluation matrices such as classification report, confusion matrix, and ROC and ROC curve and AOC. So that will be using data. So next we'll be having different learning rates, and we'll try to figure out which model is the best. For the gradient boosting classifier, we'll have initially 20 estimators, and learning rate will be based on these inputs. And then these are the max features and max depth of the tree we'll be using for this. Now let's try and run this. These are the different accuracies of this model. Okay, now let's evaluate the performance. So we'll be using classification code. According to classification code, this is a confusion matrix. So I think the model performs pretty well, because there are large number of true positive and true negative, and the false outputs are less in number. Okay, and these are the reports of our precision recall. You can also see the AOC and ROC curve. So the area under the curve is 0.8. It means it's having a pretty good amount of outputs as true, basically what it should be. This was all about the gradient boosting. Next we can have a look at something called as XgBoost. So XgBoost is yet another advanced version of gradient boosting. We will be using some better techniques to perform this. So we are doing nothing much. We'll just importing train press split, and basically the data set here is, let's see what's the data set. It's a house price prediction data set. So we'll be predicting the house prices of our model. So we are importing train press split and imputer. Imputer is basically if there are any missing values in the dataset. It tried to fill it based on the mode, median, or mean, based on the type of the class it is. If it is a regression continuous class, then it will be representing it with the mean or the zero values. If it is a classification object class, it will be obviously putting it with some mode or some predefined value, or maybe some try to add some bias on this data. So we'll be importing our data and running imputer and fit transform on it. So let's run it. Now we'll be importing XgBoost regressor and we'll try to fit on it. Okay. And notice that it is not coming from SQL, it is come from XgBoost library. Okay. Now we'll be predicting, and let's see what is the mean absolute error. So the mean absolute error is coming out to be 1896. Okay. After that, we can tune the model based on some hyperparameters called as n estimators and early stopping rounds. So first we'll try to define the n estimators to 100, and let's see what happens. And it will stop after 5 rounds, because if you don't stop it, it will have some default parameters for the stopping. So let's try and run, and this is our model. And there is one more parameter which we can use for model tuning, that is learning rate. So let's have different value of learning rate. The conclusion is that XgBoost is a very flexible algorithm, and we can easily use it for uh, that hyperparameter tuning and all. So that's it for the practical implementation of the boosting algorithm. Thank you, and see you next time. Bye bye.